Hi everyone, my name's Bridget. Like some of you, my eyeball still has not come in yet either. I'm gonna have to contact Amazon because I ordered it forever ago and see what's going on. But I printed out this diagram, so that's what I'll use for now. So first the light is going to go through the cornea, which is right here. The cornea's purpose is to focus the light and protect the eye. The light then is going to go through the anterior chamber, which comes right after the cornea, and it consists of fluid right there. Then you'll see the pupil, which is the black hole in the center of the eye, which is right here, and it's surrounded by the iris. So it's in the center of the iris, which is the colored part of our eye. The iris's function is to control how much light is going to go through the pupil by using its muscles to constrict and dilate. Then the light will hit the lens, which is this white part right here. The lens separates the anterior and posterior segment. This will focus the light again, and it's going to take what we see and flip it upside down. The light then travels to this big area called the vitreous humor, which is all of this right here. This is a clear gel-like material, and as we age, it starts to liquefy. The light will then hit the retina, which is back here. This is clear tissue in the back of the eye. The retina is made up of 9 layers, and it is in charge of capturing all the rays and turning them into light pulses. The last layer of the retina is called the photoreceptors, and it contains the rods and the cones. So the rods allow us to see at night and perceive motion, and the cones will allow us to see detail and color. After the retina layers, you'll find the macula, and this is the area of our finest vision, which is right back here. Underneath the retina is the retinal pigment epithelium. This area has a lot of pigment, so the light is very attracted to it. It also nourishes the photoreceptors layer, and which I said earlier, they contain the rods and the cones, so it provides them with glucose and oxygen. At the outer segments of the rods and cones, light is converted from light energy to chemical energy, and then to visual energy. So this absorbed light will cause chemical changes in the visual pigment of the rods and cones. This pigment is going to be energized, which causes the rods or the cones to be stimulated. After it's stimulated, an electric light impulse is created. This nerve impulse is transmitted from the photoreceptor layer to the first synapse in the outer synaptic layer, which starts the whole process of vision. Here it is transformed to the middle cells and hits the second synapse, which is the inner synaptic layer, and the middle nerve cells connect to the ganglion cells. The cells exit the eye finally at the optic nerve, which is right back here. These are all the nerves, and it's going to exit right here. So now that the cells have exited the eye, the nasal fibers will cross to the opposite side, but the temporal fibers do not cross. They stay straight, and then the nasals kind of go like this. Next, it's going to make its way to the lateral geniculate nucleus, where the other synapse will occur. The optic radiations will carry the image back to the visual cortex, which is located on the occipital lobe of the brain. And this is when we will start to make sense of what we're seeing, and the image will be flipped back around the right way. And that's pretty much the entire optical cortex.